So I said like one Rankine cycle will have one turbine, all right, one boiler, then one pump, then condenser, and I have to show all the arrow direction also, and this is turbine. Now turbine I am showing in specific shape I have drawn. Why? What is happening? This is temperature, pressure high, right? And turbine, what happens? Turbine will have one shaft. Okay, so turbine will have different stages. Initial stage will have lower, smaller blade height. Then once you go towards exit, you will have larger blade height. Okay, so blade height will be increasing actually. So one rotor, one stator, rotor, stator. So I'll draw like this: stator, rotor, stator, rotor. Okay, so similarly this side also will be there. This is shaft. Okay, so initially turbine is getting very high temperature, high pressure steam. So small volume is there. After turbine first stage is called stage. In pump I told like one rotor and stator will be one stage. So here also we have one stator and rotor. This is called stage. So first stage will have smaller size, diameter will be smaller, and next stage will be larger diameter, further diameter larger, larger, larger. So diameter will be gradually increasing. That's why whenever we draw turbine, we draw like this. Okay, so this diameter D inlet may be, D outlet may be. Okay, and whenever you are talking about steam turbine, there will be several stages. Okay, normally 3, 4, 5, 6, 7, many stages will be there, so that they can get maximum amount of energy from the steam. So energy loss will be more and performance will be more. Energy loss will be minimized and performance will be maximized. That's why this turbine is drawn like this. But if we draw compressor, here I am not using, but in later stage I will use compressor. I will be draw opposite way. Compressor I will be draw like this. I will be drawing like this. Okay, compressor means you are compressing, large volume you are taking, you are compressing. But turbine, if I draw, I will draw like this. Okay, so you should follow this common notation people are using. Okay, this is compressor, this is turbine. Okay, compressor also may have many stages. So later stage when I will discuss about gas turbine, so there I will discuss about compressor and turbine both together. Now turbine will have normally axial turbine. Okay, so detail later we will discuss. So normally it will be axial turbine. For the axial turbine, I already told that axial turbine, wind turbine, this axial turbine. So one vertical axis is there, a vertical pillar like thing is there. Then one axis shaft will be there. So shaft around it will be rotating. So fluid will be flowing axially of the shaft, parallel to the shaft. So that's why it's called axial turbine. But I had shown you the pump, that is radial. So fluid is coming and directly it's changing the direction, that will be radial turbine. So radial turbine also possible. So normally axial turbine will be used. And this is multi-stage because stage 1, stage 2, many stages will be there. So this is a multi-staging possible, multi-stage turbine. Okay. Now if you watch the movie Titanic, so you may have noticed that some piston moving up and down. That is actually not turbine driven system. That is called marine engine or reciprocating steam engine. Okay, so the Titanic movie or old engines, okay, those are reciprocating steam engine. Later we will discuss how this reciprocating steam engine works. Although majority of the steam engines are replaced, but still there some are in operation. So we will discuss about this turbine thing basically. Okay, so this turbine related steam engines are getting replaced, but still very large systems they are using turbine system because little or no vibration, low weight, minimum space requirement. So, they can make very compact system also, and they can use waste heat and other heat also for running the system. And condenser. So, condenser basically some pipe will be there. Okay, I already discussed that heat exchanger section. So, multiple turns of pipes will be there, and heat will be going out from the pipe. Okay, inside if steam is there, outside let us say ambient temperature is there. So, heat will be coming from hot to cold body. So, this is called condenser, okay, or heat exchanger. Simple term is heat exchanger. Condenser is an heat exchanger. Condenser is a heat exchanger. Okay. Now next is pump is there. So where is the pump? Pump before boiler one pump will be there. Okay. So that pump can be centrifugal pump or jet pump. Previously people were used to use one ejector. Ejector. What is ejector pump? So this is called feed water injector. Okay, feed water injector called ejector. So ejector pump is like this. I have one venturi or one pipe is here, okay, and you reduce the pipe size like this, and you create such a system like this. Okay, so you pass very high pressure steam through this channel. So when steam is passing through the narrow channel, the velocity will be very high. Okay, at this location, maybe A, B, C, just I put name. Nearby A, velocity will be very high. When velocity is very high, pressure will be lower. So when low pressure is there, low pressure will be sucked from this one. So this is primary fluid. Better I will draw another slide and I will explain. So ejector I will draw. Ejector is like this. One pipe is here, and you reduce size, make a nozzle, and make another arrangement. Okay, like this. So high pressure fluid or steam, okay, and this is water, feed water. Feed water means I have one boiler, okay, so boiler fluid is circulating, right. Fluid is circulating like this, the pump delivering to the boiler, so that water is called feed water, okay, this feed water. Okay. Now this feed water boiler pressure is very high. You can see the TS diagram. Boiler pressure is higher, but pump pressure, intake pressure is lower. Okay, but still pump is delivering to fluid to the boiler. So how they are doing? So they are using steam. Boiler is producing steam, high pressure steam. That same steam they are creating one jet. Okay, and when high pressure steam passing through this small narrow channel, it will increase velocity. Let us say initially velocity v, here velocity v. So what will happen? P by rho g plus v square by 2g equals p1 v1 rho 1 p2 rho 2g plus v2 square 2g. Okay, you can see pressure, let us say assume density constant. Now if pressure is changing, let us say initial pressure P, velocity V, velocity changing upstream, the larger diameter pipe pressure is high. Okay, now fluid is flowing through narrow channel. So narrow channel means velocity will be increasing. When velocity increasing, pressure will be dropping actually. When pressure is dropping, this location A I marked here, location A will have low pressure. This is ejector, jet ejector, injector. Okay, boiler water injector. The low pressure water will be injected into boiler using ejector. Okay, so you are creating very low pressure, high velocity, high pressure fluid is there. You create narrow channel. Narrow channel means fluid will be same amount of fluid going through small channel. When it is going through small channel, pressure will be dropping. When pressure is dropping, the water, feed water will be sucked. feed water will be sucked and it will go to the boiler. Okay. So, this way this jet ejector works. Now, newer systems they remove this one and they are using centrifugal pump. Okay. Centrifugal pump I already discussed in previous lecture that there will be radial type centrifugal impeller. So, using radial pump you inject high pressure water or feed water into boiler. Okay. But still many people are using this jet type ejector. So, you create narrow channel, fluid velocity increasing means their pressure will be dropping because Bernoulli's equation, this is Bernoulli's equation. Okay. So, Bernoulli's equation says if pressure increasing, velocity will be decreasing or vice versa. This is actually energy equation. Okay. So, when velocity increase, pressure reduced, so feed water will be sucked and it will be delivered to your boiler.